The next topic after the standard IO streams and file IO streams, in that we have unformatted IO operations. Unformatted IO operations. Unformatted IO operations are divided into two categories. The same categories, standard and file. The first one is that unformatted standard IO operation, unformatted file IO operation. So these are the two different types of IO operation, unformatted IO operations. Let us see the first one, unformatted standard IO operation. Before also we have seen standard is also known as console, unformatted console or standard IO operation. When a C++ program that includes the IO string classes is being executed, four objects are created and initialized. They include the following. See, when a C++ program includes the class called IO stream, see IO stream. So we can use the objects called cout, scene, error, log. So these are the four objects we can use when we import an class, when we import a header file called IO stream. This is unformatted console or standard IO operation. We'll discuss each and every object in detail. The first one we'll see is that cout. Cout, generally what is cout? Cout will use for a display purpose, writing to a file. When we use cout, we'll write something to be print, writing to a file. Cout is an instance of OStream class. It is an instance of OStream class. OStream, we have learned before what is OStream. The OStream is nothing but to get an output. Output should be displayed. So the cout object is connected to a standard output device, which usually is the display screen. So the cout always connected to a standard output device. The output device is nothing but a display screen, because when you are writing something, it should be displayed on the display screen. That purpose we'll be using cout. We use stream insertion operator, which is written as this. This is known as a stream insertion operator. Sorry, two less than symbols. That is nothing but, this operator is nothing but insertion operator. The insertion operator may be used more than once in a single statement, as shown below. And endl is used to add a new line at the end of the line. See, in a particular statement, we are using mostly cout. In a particular statement, we can use a single uh, insertion operator, or else we can use a multiple insertion operator. See here, in the syntax, we have given a char string as an hello C++, and we have mentioned cout. This is one of the insertion operator. This is one three insertion operator we have inserted, and also we can insert many more else. And end. Why we use endl? Endl is nothing but end of the line, or else when we want to go for a new line, we'll be using endl. If we won't give endl over here, the next line will be continued after this line. So that is the purpose of giving an endl. End l. Let us see the program of cout. Till now, whatever we have done in each and every program, we have seen a cout. This is just to show a cout program. We have included IO stream using namespace std, hash include conio.h, and we have declared the main function. In a main function, open the bracket, char string. That is nothing but to note the string which you are giving. Hello C++. And in the cout, we have given value of string is, and the string which you have given in the char hello C++, plus will be printed in the str place. In place of str, it will be printing hello C plus plus and L get ch and written 0. This is the how output you will be getting. Value of string is that you have given in the C out. So it has displayed that. And hello C plus is nothing but you have mentioned in a character string. So that one is displayed. This is cout program. The next one will go for a cin. Cin is nothing but reading from a file. Whereas cout is writing to a file. Cin is reading from file. Whatever we are reading, whatever the things variables we are giving for a particular program, that variable need to be read uh, read by a cin. Scene is an instance of iStream class, which is input class. The scene object is connected to the standard input device, which usually is the keyboard. So when we type something that input, when we give some input, so always the object is connected to the input device because it is for the input which we are giving. So we use the stream extraction operator, which is written as an 2 greater than marks. Extraction operator. This symbol is known as extraction operator. Stream extraction operator to extract the value and store it in the given variable to store. Like it extracts the value which you have given and it stores the given variable. The stream extraction operator may be used more than once in a single statement. Suppose, see, if you are giving a variables like name and age in the scene, in a particular one single statement you can give both the variables, or else you can give it as an individually, like cin extraction operator name, cin extraction operator age. This is how you represent a cin. Let us see the small program for cin. See, this is a program for scene. As include IO stream using namespace std is nothing but using namespace std is nothing but it is a standard library where we can get all the we can get some uh, objectives in the standard library files in the library. As include conio.h int main open the brace, and now we have given a character name equal to 550. Sorry, this is a size that which we can give, and see out is an enter your name, and that name here you have mentioned the variable name, so that variable need to be taken as an input. That's why it is seen your giving extraction operator name as a variable, and again you are mentioning cout your name is name. This name, particularly what the name you have given from the keyboard, what the name you are giving, that will be print in the place of an name. Endl get ch and written 0. So the output will be like this. Enter your name. Your name is ABC and your name is ABC. It will be printing the display statement your name is, and what you have entered the name will be taken and seen, and it will be store your value, and it displays the it read the information and displays the information. This is cin. The next one we go for c error. C error will be writing as cerr is an instance of ostream class. Ostream is nothing but output uh, output stream. um, this error object is connected to the standard error device. So this particularly it is always connected with an error device, which is also a display screen. But the object error is unbuffered. What is unbuffered? Unbuffered is nothing but immediately written to a device. So suppose when any program has some error, um, like any error is mentioned in the program, so immediately it written to the device. That's why C is called as an unbuffered. C object is nothing but unbuffered. Unbuffered is nothing but immediately written to a device. So this is an error device. Even the C AERR is also used as a stream insertion operator, which is written as an two less than symbols. This is called stream insertion operator. Let us see the program for CERR. IO stream using namespace std conio.h int main character string equal to unable to read. You have given a string as an unable to read. uh, CER, this is particular error message. So it is we have given as an error message. This is string. The string which you have given that will be placed in the place of this endl get ch and 0. So you'll be getting the output as error message equal to unable to read. So this is a program for CERR. Next we'll see the CLOG. CLOG is an instance of OStream class. OStream is nothing but uh, output device. The CLOG object is connected to the standard error device, which is also display screen, but the object CLOG is buffered. So before is unbuffered. That means immediately written to a device. Whereas buffer is nothing but temporary storage of data. Uh, Temporary storage of data, when we open something like when the internet is low, it will be buffered. So it is nothing but it is a non-sequentially before it is read. It's like increasing decreasing the speed up decreasing the speed of nothing but temporary storage of data. Buffered is nothing but temporary storage of data. So the CLOG is also used as a stream insertion. We can even for a CLOG we can use a stream insertion operator. We'll see the program for CLOG. We have included IO stream using namespace standard std conio.h int main char string equal to unable to read, and you have displayed CLOG error message. And the string will be placed in the place of this endl gets its written 0. So you'll be getting the error message unable to read. So uh, when you are seeing this, you have not observed any difference between the C error as well as a C log. See, we would not be able to see any difference in C out, C error, and C log with this small example. But while writing and executing a big programs, then difference become obvious. Uh, Obviously, so it is a good practice to display error message using CRR stream to log message using CLOG stream. So, so this is nothing but uh, uh, you have not find out any difference between these three programs, because these three programs are doing the same thing. Even the cout will do that. The print statements error is also doing that same, and clog is also doing the same. While writing these much small programs, you are unable to notify what these things are doing. If you write a big programs, if you are writing in a huge number of programs, you can observe the difference between them. So whenever there is an error message, it will be very nice that it will be make you a good practice that it displays the error message using CER and displays the log message using CLOG stream. So these are the four different types we have learned in unformatted IO operations, unformatted standard IO operation. Let us see the second one, unformatted file IO operation. We'll see what is unformatted file IO. Unformatted file IO operation is this. Streams provides a uniform way of dealing with the data coming from the keyboard or hard disk and going out to the screen or a hard disk. So unformatted this file IO operation is nothing but it provides a uniform way of dealing. That means a particular way, particular pattern of dealing the data coming from the keyboard or the hard disk, and data going out to the screen or a hard disk. So coming from the keyboard or a hard disk and going out to the screen or a hard disk is nothing but unformatted file IO operator. To open and close files, we create upstream and upstream objects. When we want to open a particular file, we need to use an upstream and upstream objects. So this IO stream objects maintains a flags that report on the state of your input and output. See this particularly this IO stream maintains a flags. Uh, those flags are nothing but EOF, bad, fail, good. So these are the flags that report on the state. Like these flags, suppose in your program, do you have any problem? This flag will report the state whether it is in a EOF, whether it is in a bad condition, whether it is failed or whether it is a good. So this is the purpose of this. Let us see in detail what is EOS. EOF is nothing but end of a file. A function EOF returns true. When you get EOF means true, returns true if the IO stream object has encountered EOF. When you get this EOF statement is that when you get this EOF flag is nothing but when you get to the end of the file, when end of a file is true, so you'll be getting EOF flag. So the next one is that bad flag. Bad flag. The function of bad returns true if we attempt an invalid operation. Suppose if we give an invalid operation, the you will be able to see the bad flag. Next one is that fail. The function fail returns true anytime bad is true or any operation fails. Whenever you'll be getting the statement, you'll be getting the flag of bad, that execution has been failed. So even you'll be getting an flag called fail also, or an operation fails. So anytime you'll be getting bad is a true, when it becomes bad true. So even the fail also becomes true. That is nothing but you'll be getting operation fail. So you'll be getting the flag called fail. And the last flag we have good. The function good returns true anytime all three of other functions are false. Whenever your whenever this three function EOF, bad, fail are being false, whenever in a program these three things have not yet reported, these flags are not yet reported, so the function, the programming is in a good condition. So you'll be able to see the statement of an you'll the good statement, the good flag will be reporting at the particular time. So this is nothing but unformatted file operator, IO operator. It is nothing but you'll be having a particular flag according to the file. Um, you need to open a file and close a file with the help of an upstream and upstream objects, and you will be having some flags that will be reporting according to your program.